Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to talk about maturity value, present value, and future value. The definition for maturity value of money is the amount of money, including principal and interest, at the end of a transaction. So if money is invested into a particular term deposit, for example, maturity value refers to what that amount of money will grow into, including the interest. So let's take a look at some formulas that you're already familiar with. We've talked about them in simple interest. The formula for simple interest is principal plus interest. It's also the formula for maturity value. And we know that interest is principal times rate times time. Then, if we factor out a P from both terms, we're left with 1 plus R times T. So MV is maturity value, P is present value or principal, R is the interest rate. Typically, interest rate will be given as an annual rate, and T is time. You have to make sure that these are consistent. If your interest rate is an annual interest rate, your time has to be in years. If it's a monthly interest rate, your time has to be in months. If it's a daily interest rate, your time has to be in days. Let's take a look at an example. Shannon placed $20,000 in a 180-day term deposit, earning 3.75%. It doesn't say annually, but we assume that unless it states otherwise. What is the maturity value of the term deposit? So the formula we're going to use is this. Before we plug into the formula, you might find it helpful to organize the information with a little bit of a timeline. And we're going to start the timeline today. We know that the value of the money today is $20,000, so that's P, present value or principal. We're trying to find maturity value, how much is the money worth in 180 days if the interest rate is 3.75%. So we've got P, we don't know maturity value. Our time is in days, we need to change that to years, so we do that by dividing by 365. And our interest rate as a decimal is 0.0375. Now that we know these amounts, we can plug into our formula to find maturity value. If your calculator is following orders of operation, you can type it in as you see it with the brackets. So 20,000 times bracket 1 plus 0.0375 times bracket 180 divided by 365, end of bracket equals. And we get a maturity value of $20,369.86. Now let's talk about present value and future value. The definition of future value is very similar to maturity value. It's the amount of principal with interest at some point in the future. However, it might not be on the maturity date. It could be at any point in the future. So the formula for future value is the same as we used for maturity value. It's going to be principal plus interest. And interest we know is principal times rate times time. If we factor out the principal from both terms, we'll be left with P times 1 plus RT. And we're just going to replace P with PV for present value. Now let's take a look at examples where we're finding one of these values in the formula given the other three values. In our first example, Carol has a $1,500 loan payment due today, but she would like to defer the payment for 4 months. How much is the equivalent payment 4 months from today if she is being charged 6.5% interest on the loan? So again, you can do a little timeline. Today, the money that's due is $1,500. So that's our present value. We want to know the future value at 4 months if our interest rate is 6.5%. So in terms of our formula, R will equal 0.065 as a decimal, and T is equal to 4 months divided by 12, since there are 12 months in a year. Now that we know these values, let's plug them into our formula. Again, make sure that you're following order of operations. You want to do what's inside of these square brackets first, and you're going to do the multiplication before the addition. Once that's completed, then you can multiply by 1,500. You should get $1,532.50. Our next example asks something a little bit different. It says what amount would be equivalent 90 days before an obligation of $2,500 is due if the money can earn 5.5%. So in this case, we know that $2,500 is due 90 days from now. So basically what we want to find is how much money would need to be invested for 90 days at this interest rate so that it would equal $2,500. So let's get this information on our timeline. So today, do we know the value today? No. So we don't know present value. Do we know the amount in 90 days? Yes, we do. That's $2,500. So that's our future value. Our interest rate is 5.5%. So as a decimal, that's 0.055. And our time is in days, 90 days. So we need to divide that by 365. So in terms of our formula, we're not solving for future value. We know that. We're solving for present value. So what we can do is isolate present value by dividing both sides of the equation by 1 plus RT. So future value divided by 1 plus RT will equal present value. So to find present value, we plug in future value of $2,500 divided by 1 plus R is 0.055 and T is 90 divided by 365. There's a couple of ways that you can calculate this. If you want to do it step by step, remember that even though there's no brackets here, they're assumed. So that means we have to calculate this whole value first, which means we do multiplication first, then addition. And then when we have that value, we want to divide our numerator by that value. If you do it that way, just be careful you're not rounding off as you're going. Make sure you use the memory function on your calculator so that you store the whole value. The other way you can do it is let your calculator do the work for you. If it's following order of operations, you're just going to type in 2,500 divided by bracket 1 plus 0.055 times 90 divided by 365, end of bracket, equals. You should get $2,466.55. So this amount of money will be worth $2,500 in 90 days at this interest rate. Our next example is a little bit different again. It says a financial institution offers to lend you $12,000 for 1 month. They say you will have to pay back $12,090 at the end of that month. What interest rate are they charging? So again, let's organize our information on a timeline. Today, that money, so present value, is $12,000. In 1 month, that money is worth $12,090. So that's going to be future value. We know time is 1 month, so that's 1 divided by 12 years. And interest rate is what we're finding. So let's plug these values into our formula. Now that we have the values plugged in, we're going to solve for R. So one thing that we can do is get rid of these brackets by distributing that 12,000 to each term. So 12,000 times 1 is 12,000. And then 12,000 times R times 1 over 12 is this. And we can simplify that. This simplifies beautifully to just 1,000 times R. Now, in order to solve for R, we need to isolate this term. So that means we're going to subtract 12,000 from both sides. And now, to solve for R, we're going to divide both sides by 1,000. So we get R equal to 0.09, which is 9%. So this financial institution is charging an interest rate of 9%. Let's do one last example, and this one is going to be an example of finding present value again. You owe $1,456 in 6 months. If a fair interest rate is 8%, what could you pay today to be equivalent to this amount in 6 months? So let's organize our information on our timeline. We don't know today's value, that's present value. That's what we're going to find. But we do know the future value, the value in 6 months, is $1,456. Our interest rate is 8%. And our time is 6 months, which would be 6 divided by 12. So in this case, we're solving for present value. So we can isolate present value by dividing both sides by 1 plus RT, and that gives us future value divided by 1 plus RT. Now let's plug our known values in. So future value is known, interest rate, and time. And notice 6 over 12 can be reduced to 1/2. Anytime you want to do that before you do calculations, that's fine. And you should get present value equal to $1,400. So anytime you're doing problems that involve future value, present value, you're using this formula. And you need to know 3 of those values in the formula to find the 4th. And if it's maturity value, it's basically the same formula, except we call future value maturity value. And we call present value principal.